Is that what you're referring to? Oh,
Yeah.
I never looked up. Okay, so let's review what we talked about on Thursday. Now, from the quantum mechanic model, they want to be able to identify and configure every single electron in an atom. And they do that by looking at four identifiers. Okay. So what shell is the atom located on? Okay, that's the same as a period on the periodic table. Well, say we're looking at helium, for example. That would be okay. So helium would be 1s2, and the two electrons would have opposite spins in the orbital here. Okay, so this is a shell. Subshell. Number of electrons in the subshell. And this would be the spin of the electron. Those are the four factors that uniquely identify all the electrons on the atom. So let's look at okay, let's look at let's say aluminum. Okay, so it's in the third shell. Nice. It's in the third shell. It's in the P subshell. And it's got one electron. And that's the spin. Now we have to fill in all the other electrons as well. Yeah. How do I know the spin? Well, it's either this way or that way. Punt. Doesn't matter which way you put it. Just if you put another one in that orbit, it has to be opposite. So some books always say, always go up. Is that what you mean? Correct. As long as the next one is the opposite, though. There are no exceptions to that. They have to be opposite. Some books will tell you always go up on the first one. Really doesn't matter. If there's more than two, depends on the subshell. Some subshells have one orbital like S's. Some have three like P's. Some have five like D's. Some have seven like F's. So it depends which one. Okay. Let's finish this out though, because what I've done is I've done the valence electrons. So the 3s2 and the 3p1 are the valence electrons for aluminum. All the other electrons above it are core. So let me so that's going to be so the core electrons are going to be the ones above it. That'd be the 1s2, 2s2, 2p6. Those are all core. Nothing ever happens to them. They're super, super stable. That's why they always look at the valence electrons, which are not stable. They have to bind up with something else to become more stable. Okay, so let's look at chlorine. Now, chlorine is going to have the same core electrons as aluminum. This is in the same shell. So this is going to be the same. So chlorine is 5 into the P subshell. Remember, the P subshell has a total of 6 electrons, 2 per orbit. So we have 1, 2, 3, 4, 5. So that's what chlorine would look like. And notice I filled them 1, 2, 2 before I paired them up, because it's more stable to separate them than to pair them up. But once you filled up everything with just one, then you start pairing them up. Okay, and some people like to include the S in that. Okay, so is everyone okay with where we are with this? That's just this one here. This would be the S's. And this would be the P's for the orbitals. Yeah. Yes, that's a good assumption, but frequently they want you to put it there anyway. But you're absolutely right. It's full. Because the only way to get to P's is to fill the S's first. Yeah, exactly. Well, I didn't. I should have. Should have as well. Okay, now there's a glitch in all this. And the reason why I wanted to cover this today, hopefully some of you are studying for your test tomorrow and went over electronic configuration. Okay, so the deal is, what if we did iron? Now notice it's in the middle. That's a D block. D block. So we've got the 1 S's, 2 S's and 2 P's, 3 S's, 3 P's, 4 S's. And what happens when we get in the middle? We get into the D's and the D's are one down. So you'd think it's in the fourth shell, right? It's not though, in the third shell. So we're going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3, D, 1, 2, 3, 4, 5, 6. Okay. So whenever you're moving into the D's, it's one down from the major shell. Think of the D's as being dumb. So they're down one. And in fact, when we get to the F's, it's down two. We're not going to do F's though. Okay. Now we need to do orbitals as well. So we're going to have the s orbital there. Now D has a potential of 10 electrons. So that means that's 5 orbitals. And those are the 6 electrons in the 5 orbitals. Okay. I'm sorry. Yeah.
So D is 5.
On the bottom, F is 7, 5, 3, 1.
So 7 on the bottom and 3.
Hmm?
7 orbitals on the bottom,
Yeah.
correct?
Mhm.
Or yeah.
Yeah, because there's 14 across. 14 divided by 2 is 7.
Oh, so you could, okay.
10 across. 10 divided by 2 is 5. 2 divided by 2 is 1. 6, that's 3.
Okay. And what about S? S is like, this is only two.
Yeah, it's
Oh, it's part of that. So
Yeah. Okay, so let's do another one involves D's. Let's do yeah. Yeah. That's is if you put them in the same direction, it's more unstable than if you go like this. If you go like this, you have the north and south because they have a magnetic part to them. So when you put two magnets together, there's one that want to repel, other wants to attract. Have you done that with magnets before? Okay, so think of electrons as having a magnetic component. When you put them in there, it makes a difference which direction the magnetic component is facing. So to make the most stable arrangement, you want them opposite, north to south, south to north. I said to put a single one in each one first. Then if you have some electrons left over, then start pairing them up. And guess why the reason for that is? Always say stability. If in doubt, it's more stable. And the reason it's more stable is they're spreading out those quote unquote magnets in the electrons. Then you're forced to pair them up when you don't have a choice. That makes sense? All right, so let's do another one involving the D's here. Let's do bromine here. Okay, going to be the same thing. Only this time, we're going to go all the way through the D's. And there are 10 D electrons there. core and valent. So the Ds aren't a big deal. There are two, when you get into your next class, depends who's teaching it. Sometimes they teach actually three exceptions. That's the chromium, copper, and carbon are the three exceptions. And depends on the class. 1A for sure, 3A for sure, or 3B, it depends on which semester is being taught. And then I'm not sure about 2A, whether the exceptions are
What about
taught.
this class?
No, we're not going to do those. It has to do with bond hybridization. And I did. The little arrows. Oh, I'm sorry. Okay, so that's kind of it for electronic configurations. It really isn't too bad. There's a lot of details there though, but there's a pattern. Now in your 1A class, 2A class, or 3A class, they may show you a shortcut. And that has to do with the core electrons. There's two ways to do core electrons. You can substitute in a noble gas configuration, which is the same, or you can just write it out the way I did. And they'll tell you, in our class, we're going to write them all out. I want you to make sure you understand the core is there. But it depends on who teaches your 1A, 2A, and 3AB class, whether they allow that or not. Yeah.
You just explained how that.
Yeah. If you count how many are in the D block, remember, this is the D block. And if you count over, there's 10 in there.
Okay.
That's why we have 5 orbitals, because there's 2 per orbital. And then this is the S's over here, P's and F's. And if you count the F's, there's 14. That's why there's 7 orbits. Yeah. Yeah, you can either start from the beginning or you can work backwards. You get to the same place. Like I usually start from at the end, show you where it is, and then we just fill it in up to that point. Okay, that concludes Unit 2. So what I want to do now is go over practice tests I gave you. And I included a key, but I want to just walk you through it. Now your test is going to have more room than this one did. The reason I did it this way, I was trying to force people to use a separate piece of paper. Even at the header, I said, answer questions on separate paper. And half the class wrote really, really tiny to fit it all in on this. It's like, so it didn't work. So your tests, I have lots and lots of room for you to write your answers up. Okay, so I guess I should shut this door. Okay, so we're filling in this here. And I warned you there's both ions and neutrals there. How can you tell an ion from neutral on that chart? Huh? Yeah, the ion will have a charge, neutral will have a charge of 0. So when the electrons and protons are different, it's an ion. If they're the same, it's neutral. Okay, so down here, you see that nitrogen has got a charge of -2. So that's the ion part. So that means the other part is the neutral part. So that means, okay, now these are always going to be the same atomic number of protons. That means automatically 56. And then 56 is barium. And we need an atomic mass. That's N plus P. And we just put the isotope on top, atomic number of protons on the bottom. And then that would be called barium 136. Because this is neutral, those two are going to be the same. Okay, so chlorine 19. Notice the 19 here, 19 here. Chlorine is Cl. So we have 19 on the top, 17 on the bottom. Okay. How many neutrons do we have? Well, there's 19 total, 2. Because 17 plus 2 is 19. Electrons are the same because it's neutral. So that's that. I have to somehow indicate a charge. Because if I don't somehow indicate a charge, you have to assume it's neutral. Okay, so let's look at the ionic part. Any questions about the neutral one? Okay, notice right away, protons, electrons are not the same, hence that's an ion. Okay, what charge is it? Positive or negative? Positive because there are more positives than negatives. By how many? 3. So that's going to be a +3 charge. Atomic number of protons are all the same. So what atom corresponds to atomic number 13? It is aluminum. And it's got an atomic mass of 20. 13 and 7 is 20. Atomic number is 13. So this is going to be aluminum 20. Everyone okay with that? Yeah. How did I get aluminum 20? Oh, the 3 plus. Okay, look at 13 pluses, 10 minuses. Okay, so let's do the last one here. Nitrogen. And it's 18. And nitrogen is next to oxygen up there. So how many neutrons? 11. 11 and 7 is 18. And electrons, okay? Okay, it says -2. That means we have 2 extra electrons. Well, how many protons do we have? We have 7. 7 positive protons. And we have to have 2 more negatives. So how many electrons? 9. 9 negatives, 7 positives. We have 2 extra electrons. That makes it the charge -2. Okay. All right, these questions. How is an ion different from a neutral element? We already talked about that. So what would that be? All you need to say is natural element has electrons and protons are equal. And with an ion, electrons are not equal to protons. Okay, what are the 2 types of ions? Well, the positive and negative one. The names are cations for positive, anions for negative. What's an isotope? Using carbon-12 and carbon-14. Isotopes isotopes differ in the number of neutrons. Carbon-14 has 2 more neutrons than carbon-12. 6 protons for both of them. Just the number of neutrons differ. What's the atomic number for oxygen? What's the atomic number for oxygen 16? 8. Because the protons are the same. Otherwise, it cannot be called oxygen. Okay, what's the difference between oxygen and oxygen to the -2? Charge, what else? Right, and that's what causes the charge. Yeah. Okay, so oxygen -2 has 2 extra electrons. And like he said, it's also charged. Okay. Why do isotopes have different masses? Exactly. Okay, if an element has 8 neutrons, 8 electrons, 8 protons, what is it? And what does 0 stand for? 8 protons. Atomic number is 8. Some of you are saying 0 oxygen. Huh? No, not 0. A letter. It says if an element or ion has 8 neutrons, 8 electrons, what is it? It's neutral, but what is the atom? Oxygen, right. That's where it's going. This here, what is it then? charge is neutral, you're right. It's neutral oxygen. You're right. Okay. 8 neutrons, 9 electrons, 8 protons. What's its charge? 1 what? -1. How can an element have 2 atomic masses? Isotopes, that's right. Like carbon 12, carbon 14. Those do not have equal masses because there's 2 extra neutrons there. Who remembers on the history, Rutherford? What is he known for? That's right. Yep. Yeah, you nailed that one on this. So nucleus in this famous gold foil experiment. Okay, what's the electronic configuration for lead? Okay, lead is Pb down here in the bottom. I wasn't going to cover down. Let me do lead for you, but you don't have to worry about anything above that. I mean, we're going to be working with everything above that. Let me do lead for you. Is lead. Yours is going to be easier on your test than that. I'm just. As soon as you hit the S's, then you got to deal with the F's. So you go down through all the way through the F's. There's 14 of them there. And then you come up and go through the D's. There are 10 of those. And it's 2 into the P's. Yeah, you come when you're in shell 6 and 7. So you go basically, and you come back up here to the D's, go across. And this is going to be 1. These D's are going to be 5D. These are going to be 2 less than that, 4. But we're just doing these up here.
Okay, but how, so you went from up there, you went from 3P6 to 4S2 back to 3D10.
Oh, I see what you mean. Yeah, let's, this is 1 down from 6. So it'd be 5D. Is that-
Switch, no, we switch, it's like the, we switch to 4S2 because
Well, the D's are 1 less than the S's. So the X is 6S. So it makes that a 5D. And it's the F's are 2 less than the 6. So they're 4 F's.
yeah. Okay, I'll just do it.
Yeah, but yours is going to be simpler than this on your test tomorrow. When I taught using this test, we covered all the F's and everything. That's right. And then normally I'll say draw orbital diagrams. You can't go wrong if you always draw the orbital diagrams. And like here, I said, draw the orbital diagrams for cobalt. Well, cobalt is in the D's there, halfway through. So how far in is cobalt? Let's see, 1, 2, 3, 4, 5, 6, 7. That would be for cobalt. Now that would be a typical problem for tomorrow, like doing cobalt or anything on that first row of D's there. So you could do scandium, titanium, vanadium, or any of those across there. Yeah. Seven is 7 across the D block. On which one? The one above it? Are you talking about for up top? Carbon is 6, nitrogen is 7. It's the next one. Oh, I see what you mean. Yeah. You're talking about on this, right? Like that? Oh, yeah, I forgot. Thank you for pointing that out. Yeah, I kept thinking your question responded with the one I just did. That's why I was. Anyway, yeah, you're absolutely right. Okay. And then the last thing is as far as the organization of the periodic table. Okay, so noble gases. Okay, so those are the 4 groups I wanted you to know. The alkali metals, alkali earth metals, halogens, and noble gases. Metals, nonmetals, metalloids. So the black squiggly line are the metalloids. Everything to the left are metals, including the bottom. The atoms on either side of the black squiggly line. And they keep changing depending on what tech. That's why I just put a blob in there, just so they know that metalloids are sometimes like a metal, sometimes like a non-metal, depending on what the polarity of the voltage you apply to them. And then, of course, these are non-metals over here. Now, the biggest mistake students make on doing this one, I put this on every single test, regardless of what class I teach, except for when I teach organic. And I always ask them where are the metals, and they always mess up the metals. The metals are just everything to the left of that black squiggly line, including the F block on the bottom. 99% of the stuff are metals in the periodic table. Okay, and I also supplied a key.
So it's not metals, it's earth metals specific,
It's just are they located?
so only hydrogen, alkali metals.
Yeah, hydrogen is weird. Some people put it twice. Sometimes they put it over there as well, because it acts like, yeah. You see, halogens can get a -1 charge, and so can hydrogen. That's why they put it over there.
Or halogen gas.
The halogens plural is the group. And then there's just one halogen, or when you're referring to just one, like chlorine is a halogen. But when you count all the
Is it
group,
considered gas? They just-
it's a gas when they're atomic. So Cl2. Cl by itself is never a gas. Well, I shouldn't say that. It's depends, but normally there are 7 chemicals that are diatonic. All the halogens, hydrogen, nitrogen, and oxygen. Those are 7. And those are all diatomic. Like, yeah, di atomic, yeah. Okay. So we are done with unit 2. So yeah, like the first one, yeah. And if you go to files, unit 2, do you have lab today? No, her. Could you remind me? I'll put some on. I thought I had some there, but right. I have some. But, yeah, so in lab, I'll do that. I just need to remember to do it.
So. let's-
Yeah, have you looked at the study guide? There is. I did one Thursday. Ah, okay. If you go to files, test related, you'll see one there. And it covers history, electronic configuration, PIRAC table organization. This is what we've been doing in a minute. Yeah. First page. Oh, okay. Now there is a posted key as well. There's a posted key as well. No, only test 1 and test 4. And it's going to be very similar, only it's going to involve a chemical reaction. Right. There's no key to a study guide. It's just what to study. Or the key could be. Yeah. No, Monday, you have Monday, Wednesday? Yeah, so your wet lab will be Wednesday, yeah. And it's gonna be really hot on Wednesday. And silly me, I'm going to a baseball game. So. Okay, for Monday, folks. We are done for today. Wednesday, we start unit 3. We have a dry lab for Monday, Wednesday.
What drive?
Huh?
What drive?
Right, Monday.
Oh, right. What was that? Seven.
Yeah, let me do one thing.